We all use 3D geometry in our day-to-day lives without even realizing, and they play such a vital role in our lives.
Greetings everyone, I'm Jasleen Kaur from St. Mark's Senior Secondary Public School, Janakpuri. I'm in grade 9 and today through this video I would like to familiarize you with the concept of 3D geometry, which plays a very vital role in our day-to-day lives and we use it without even realizing.
Any idea what does geometry actually mean? The word has derived from the Greek word geometron, which has derived from geometry and metron. So geometry is the mathematical study of all shapes, and one of the most powerful tool for any engineer or scientist's toolkit is 3D geometry. It comes to picture into model real-world quantities such as velocity, fluid flows, electrical signals, etc. So basically, 3D shapes or objects have 3 dimensions, which are length, width and height of an object, as opposed to 2-dimensional shapes and objects. 3D geometry involves the mathematics of shapes in 3D space and involving 3 coordinates, which are x, y and z coordinate in a 3D space. These 3 parameters are required to find the exact location of a point. Do you know that we come across so many 3-dimensional shapes and objects in our daily lives? For example, a playing dice cube or a cuboidal box.
We not only come across 3D geometrical objects in our rooms, but also when we roam around, like Taj Mahal, Jantar Mantra and other historical places also involve 3D geometry in their architecture. So come, let's have a look at them.
These beautiful monuments like Taj Mahal, India Gate, which are said to have the most beautiful architecture, also involve 3D geometry. So in 3D geometry, the position or coordinates of any point in 3D space is measured by how much it has moved along with x, y and z axis respectively. So I have made this model out of fused cardboards. In this, 3 planes are intersecting at point O, which is the vertex, such that these 3 planes are mutually perpendicular to each other. You can see that the entire plane is divided into 8 equal portions, and these 8 equal portions are known as octants. So now I'm going to reveal a super easy trick which will help you memorize that when an octant's coordinate will be positive or negative. So to begin with the x coordinate, first we'll see the first 4 octants. So in the first octant we'll write a positive sign. In the second and third we'll write 2 negatives and again 1 positive. And now for the y coordinate, we'll be writing 2 positives and 2 negatives. And 2 negatives. And in the z coordinate, we know that the first 4 octants are positive. So now, we'll see a repetition here. As in the x first coordinate there is positive, 5th one will also be positive. As the second and third are negatives, the 6th and 7th will also be negative. And as it is positive in the 4th octant, it will also be positive in the 8th octant. In the y coordinate, as the first 2 are positives, the 5th and 6th will also be positive, and the next 2 will also be negatives. And in the z, as the first 4 are positives, the next 4 will be negatives. Now that we know when a coordinate of an octant will be positive or negative, we'll locate the points of this cuboid. Here, the x point is 4, y is -1 and z coordinate is 5. So now we're going to look at some examples of finding the distance between 3 points when the points are located in 3 dimensions. So look at the point 1, 3, -5 and -4, 0, 7. And if we label them as P of x, y, z and P2 of x2, y2 and z2, the distance formula is going to be the formula mentioned. So first, we'll solve it. So it will be under root of x2 minus x1 whole square plus y2 minus y1 whole square, and then we'll add z2 minus z1 whole square to it. After solving, we'll get under root of minus 4 minus 1 whole square plus 0 minus 3 whole square plus 7 plus 5 whole square. So, this is gonna be under root of 25 plus 9 plus 144. When we'll put it together, we'll get the under root of 34 plus 144. So then we'll get under root of 2.87. So the answer will be under root of 178.